6.4.3, using 2 points to find a system for modeling. So in the last unit, we learned how to write the equation of a line given 2 points. We also saw in the review packet that when we use linear regression AX plus B on lists that contain just those 2 ordered pairs, that we got the same equation that we got by hand. Okay, there's only one line through 2 points. So the best fitting line that the calculator finds for us is the one line that we found when we did things by hand. So in the example below, we could find the equation of each line by hand like we did in the last unit, but again, dealing with real-world data, sometimes those coefficients aren't so nice. So we're instead going to use linear regression on the calculator instead. So in example 3, we're told that the percentage of households with televisions tuned in to ad-supported cable increased approximately linearly from 24.5% in 1992 to 53.4% in 2005. Okay, so if we take that first sentence, okay, and put the data in our table, so our input here is the number of years since 1992. So 1992, that would be 0. And for cable, the percent tuned to cable was 24.5. And then in 2005, so 2005, that would be 13 years later, okay, it was at 53.4. So now the percentage of households with televisions tuned into a major networks decreased approximately linearly from 48.5% in 1990, that should say 1992, to 23.7% in 2005. Okay, so again, if we put that data in the table, and that was a typo there, so in 1992, so T is 0, and for the major networks percentage, that was 48.5, and then it decreased to 23.7% in the year 2005, which is 13 years after 1992. Okay, so for each of these we have 2 points. Okay, so for cable, we had the points, if we write them this way, that look like this. And similarly for the major networks, we had the points 0, 48.5, and 13, 23.7. Again, there's only one line through 2 given points, and so we're just going to use the linear regression feature on the calculator to get those. So if we were to go to Stat 1 first, and we're going to put these 2 in L1, these 2 points in L2, and these 2 points in L3. And again, you may need to pause the recording while you get those points in your list. Once we have those in our list, we're going to use linear regression. So to do that, we're going to push Stat, right arrow, and 4. And for the first equation, we're going to use L1, L2, and store the equation in Y1. So remember, to type a Y1, we're going to do variables, right arrow, 1, 1. Okay. And then for the major network data, we'll do the same thing. Stat, arrow over, choose option 4, L1, comma, L3, and this one we're going to store in Y2. So again, to type Y2, we can hit variables, right arrow, 1 and 2. Okay. And again, you may need to pause the video while you enter these pieces. Okay, so on the output screen then for the first one, when we did L1, L2, and Y1, we should see Y equals 2.223x, so we're going to replace that with a T, plus 24.5. And for the major network data, we get negative 1.908 T plus 48.5. So now if we try to solve this system using the substitution method, we can think of these being equal to y, and again we can think of these as either x's or t's. Okay, so if we rewrite those as 2.223x plus 24.5, has to be equal to negative 1.908x plus 48.5. So again, if we bring both x's to the same side of the equation, and then we get 4.131x plus 24.5 equals 48.5, because here we're going to get a 0x. Again, we only have one term now with an x, so to isolate that, we're going to subtract 24.5 from both sides. So we'll get 4.131x equals 24. And so now if we divide by 4.131, we get x is approximately 5.810. But again, to solve a system, we're trying to find the ordered pair that makes both equations true. And so currently we just have an x. We don't have the full ordered pair. So to get y, we can use either equation. So if we take the first one, again, these two lines intersect at the point, so their y coordinates will be the same. So no matter which equation you pick, we get the same y value. So if we plug that into the first equation, we get 37.42. So if we put that together as an ordered pair, we get 5.8 years since 1992 is our input, and our output would have been 37.42, and that was a percentage. Right, well, we can also try to solve this system using the intersect feature on the calculator. So we have our two equations and we stored them next to y1 and y0. So let's see here. And let's bring that down into view here. Alright, so again, we're going to go into y equals, and let's clear these two equations from the last problem. So next to y1, I guess I didn't have mine stored in there, so I'm just going to type these in now. So 2.223, okay, you shouldn't have to type yours in, it should already be there. X plus 24.5. And next to y2, we're going to type in negative 1.908x plus 48.5. And then let's go into the window, and we'll set it from 0, and maybe, like I said, we're just guessing, let's try 30. And zoom 0. So here's our first graph and the second one. And 30 was a bit large, we didn't have to go that far, but we do see our intersection point on screen. So we can hit second, trace, 5, enter, enter, enter. And we get our intersection point here at about 5.8 and about 37.4. So on screen here we did an x min of 0 and an x max of 30. And then we did zoom, so we needed to push window to change those, and then we pushed zoom 0. And then the intersect feature, we had to hit second, trace 5, enter, enter, enter. And on screen here, we got something that kind of went like this. And we had our intersect here was at 5.8 and 37.42. Okay, so if we explain in context, okay, our input here was years since 1992. Okay, so about 6 years since 1992. That would have been in 1998. Okay, so in 1998, okay, percentage of households tuned to cable. was the same as the percentage of households tuned to major networks. And this percentage was 37.42.